Hello students, welcome to the class of wave optics. In this section, we would like to see the most important aspect in which velocity of light is concerned. From velocity of light, one question is definitely asked into the examination. One velocity of light that we have to read is the Foucault method for finding the speed of light in the lab, and second is the Michelson method for finding the speed of the light. So these two methods are very important, and one question is definitely from the velocity of light section. So let us discuss the velocity of light. First we will discuss the Foucault method for finding the velocity of light. Here the diagram is complicated, so I will make the diagram in 3 steps and you will follow me accordingly. You will be comfortable in, you will learn the art of drawing the diagram. So see carefully. So in the first step, I have made a lens, I have taken a source of light, and then here is the plane mirror. This is your plane mirror mm, and here is the point I am considering as O, which is the center, and this distance OC, here it is the concave mirror, and when the light ray is coming from here, and here we have to take one glass plate. Here we have to take one glass plate. Take it as P1, P2. Now you see, this is the first step that I have done. In the first step, I will take a source, I will take a lens, I will take a plane mirror, and then this is adjusted in such a way that this distance OA is equals to OC. This is the center of curvature of your this concave mirror, and this point is pole. So ray of light after converging from the lens L falls on the plane mirror, so finally reflected here, and this behaves as the image. This behaves as the virtual image of the source S, and here in the returning process, when the ray of light is returning, here partial reflection takes place. So partial reflection takes place, so some portion of light is being transmitted and some portion of light is being reflected. So you will observe that a image I is being formed. Here the image I is being formed. Right now, this mirror is a stationary. Plane mirror is a stationary. I am considering R is the radius of curvature of this concave mirror. This distance I am considering as R, and this distance from lens to plane mirror I am considering as A, and from lens to source, this distance I am considering as B. R, A and B. Right now the plane mirror is a stationary. Now I am rotating the plane mirror. The plane mirror is rotated with a certain angular speed. That is a fixed angular speed, I will tell you. Now you see, when the plane mirror is rotated, then I have shown you the position of mirror by the dotted line, and here A dash is behaving like an virtual image, and in this return process, whatever is this distance, the same distance, if we consider this distance as x, at the same distance here you will get the image I dash, and it will be this is the basic diagram. This becomes X, then I dash is also X, which is observed from the microscope. So this is your basically the diagram of your Foucault method, and in this glass plate P1 P2 is inclined at an angle 45 degree. It is partially reflecting and partially transmitting. So students, we were in the Foucault method for finding the speed of light. In the first step, we have made the lens, we have made the source, we have made the mirror, plane mirror M, and the image and the concave mirror. This should be the distance of this distance. OC must be equals to OA, that is the radius of curvature. The distance of plane mirror from lens I have considered A, and the distance of lens from source we have considered B. And this P1 P2 is partially silvered glass plate which partially reflects and partially transmits. So in the first step, when the mirror is not rotating, plane mirror M is not rotating, we are getting the image I. Now in the second step, we have given the rotation to the plane mirror, and we suppose that the plane mirror rotation about the vertical axis O is so adjusted that in the time light goes from O to C and back to O, the plane mirror rotates by an angle theta with the angular velocity. Now here what I would like to tell you, the time taken by light ray to go from here to here and back to here, that means O to C and back to C. This time if I will calculate and if I will consider, then you see this time T must be equals to 2R by C. Why? Why this time? This distance R, this is equal. So R, 2R, and by speed of light I have considered C, so it is 2R by C. It is 2R by C. This is the time. And in the same time, the mirror has rotated by an angle theta. So what we can say, angular speed omega is equals to theta by T. So T is equals to theta by omega. Omega means 2 pi f. Omega means 2 pi f. Omega is equals to 2 pi f. F is the frequency of rotation of this plane mirror. So if we combine the two results, that means this T and this T is same. In this T, the distance traveled this time is 2R by C. Light ray has gone from O to C and back to O, so 2R by C. And at the same time, in the same time, the mirror has rotated an angle theta, so omega is equals to theta by T, angular velocity, and so T is equals to theta by omega, that is theta by 2 pi f. So if we make them equal, then you see what we are getting. We are getting a relation that is in this way, that 2R by C is equals to theta by 2 pi f. So we are getting the value of C is equals to 4 pi f r by theta. Here we have got the formula for the speed of light. We have got the formula. F is the frequency that can be calculated, that is known with the help of technique, with the help of technology we can find there is a method by which we can find the frequency. R is a measurable quantity, we can measure. Pi is constant, 4 is constant, that is no problem. The problem is measuring in theta only. Here the main problem is how to measure this theta, because this theta is very small and the problem is in measuring theta only. So we will try to express the value of theta in terms of r, in terms of a, and in terms of b. If theta is expressed in terms of r, a and b, then r is measurable, a is measurable, distance, b is measurable. We can easily measure the speed of light, and this is the thing that we shall be doing, that we will try to explain the value, we will try to get the value of theta in terms of r, a and b, and for that you have to remember we will be using some geometry. So this thing you have to keep in mind, that if the mirror is rotated by an angle theta, this is m1, m1, this is m. If the mirror is rotated by an angle theta, reflected ray rotates by 2 theta. This thing I will tell you. You see here a dash, a dash. A is the image of S and a dash is the image of S dash. When the mirror is rotated, then this source appears to be here, and the shifting of image is X. This X is basically the shifting of image. This thing has to be also very carefully understood, which can be measured with the help of microscope. So this distance can be also be measured. Now we will try to express C. We will try to express C theta in terms of A, R and B. So as you have seen that if this distance is theta, the reflected, if the mirror rotates by theta, reflected ray rotates the 2 theta. This is giving you the direction of reflected ray. So what we can say, theta is equals to r pi length. So we can say this distance is r. So 2 theta is equals to a dash by r. So a dash is equals to 2r theta. Take it as equation number 2. Take this as equation number 1. I am in the process of finding the value of theta in terms of r, a and b. So my main objective is to express theta in terms of r, a and b. Now see the diagram. This is your lens L and this is the position S dash A dash A. And what we can see, the two triangles are similar, triangle number 1 and triangle number 2. The two triangles are similar, therefore this distance was X, therefore A dash, therefore A dash by S dash must be equals to R plus A by B. And R plus A is how much? A dash is how much? A dash we have calculated 2R theta. Therefore 2R theta by S dash is how much? X must be equals to R plus A by B, and we are getting theta is equals to X into R plus A by 2RB. This is the value of theta. This is the value of theta. Theta is equals to X into R plus A by 2RB. This is the value of theta. If we will put the value of theta in equation 1, what we will get? 4 pi FR by theta. By theta means X into R plus A, and this is in denominator, so it will go into numerator, 2RB. So we are getting C is equals to 8 pi FR square B by X into R plus A. Now every quantity is measurable in this equation. 8 pi is there, F we can measure, R we can measure, B we can measure, X we can measure, R and A we can measure. So in this way, using this equation, the speed of light is calculated, and the speed of light we can find using Foucault's method. Now this derivation is very important because in examination point of view this has been asked many times. So basically you have to remember this derivation, and after 4-5 times practice you can easily find it. In the same way, by this speed only the scientist Foucault was capable in finding the speed of light in water or in some other medium, and then he confirmed the concept that speed of light in denser medium is less than the speed of light in rarer medium, on account of which the Newton's corpuscular theory was rejected finally, because in Newton's corpuscular theory it was the assumption that the speed of light in denser medium is more as compared to the rarer medium. So this formula you will have to always keep in mind very carefully. Now we will try to understand the Michelson method for finding the speed of light. Out of Michelson and Foucault method, one will be definitely asked into the examination. And the ray diagram for Michelson method, we take a polygon mirror. See the art of making the diagram, which is not very difficult as the Foucault method. It is simple in nature. See, this is the arrangement for Michelson method. Different mirrors are arranged. This is the arrangement for Michelson method for finding the speed of light. Here it is your polygon mirror. Many sides are there, from 8 to 32 is there. 8-sided mirror was used by Michelson. After his death, the technology developed and even it reached to 32 side. Less than 8 side is not possible. So this is your polygon mirror, and here is the intense source of light from which the ray of light is going in this way, and finally after reflection it falls on the plane mirror. Let us call it as M1. Then it falls on the mirror M2, which is kept at the focus, and then it falls on the mirror M3. This M3 is concave. Finally it falls on the mirror M4. Here again it is plane mirror M5. This is also at the focus of this mirror M4, and finally here M6 is there. This is already M3, M6, and it gets reflected on the mirror M7. This M3 and M4 are concave mirror, spherical mirror. This is polygon mirror. This is polygon mirror, and here is the telescope. This is the basically arrangement of your Michelson method, and in this Michelson method, the special point, this much arrangement is being done because the distance traveled by light from here to here, that should have a measurable value. So that this long arrangement is taken. Now in the initial experimental arrangement. Every arrangement is adjusted in such a way that the sharp image of the source is observed in the telescope. The adjustment of mirror is done in this way. Now, after that, if this polygon mirror is rotated with the help of attached motor, this polygon mirror is rotated with the attached motor. So initially the sharp image is observed in the telescope. When the polygon mirror starts rotating, flickering of image is observed in the telescope. The angular speed of rotation of the polygon mirror is increased, and at a particularly fairly sharp high value, what we observe that sharp and stable image is observed in this telescope. That specific value of angular speed of rotation is noted, and then with the help of calculation we are able to find the speed of light using Michelson's method. So this is the basic experimental arrangement. Now in the process of calculation, if we consider n as the number of sides of your this polygon mirror, then this theta will become 2 pi by n. This is the angle theta. Theta will become 2 pi by n. If the specific value of angular rotation, is omega, then omega is equals to theta by t. That means omega is equals to, what is theta? 2 pi by n into t. So we are getting t is equals to 2 pi by omega n. Here see, omega is equals to theta by t, omega is equals to 2 pi by theta is your 2 pi by n that we have calculated, theta is equals to 2 pi by n that we have calculated, 2 pi n by t. So t is equals to 2 pi by omega n. So t is equals to 2 pi by omega n. Omega is 2 pi f into n. 2 pi will cancel. So t is equals to 1 by fn. So this thing you will have to keep in mind, that time is equals to 1 by fn, and here time is equals to d by c. So d by c, and t is equals to how much? 1 by fn. T is equals to 1 by fn. So what we can say? We can say that c is equals to fn. C is equals to fn. N should be capital. So C is equals to FND. C is equals to FND means what? This gives you the expression for speed of light. This way we can calculate the speed of light using Michelson's method. Now see it carefully. One time I am again revising the whole process. You try to understand. Here F represents the frequency of this polygon mirror. N represents the number of sides of the polygon mirror. If the number of side is 8, we can take 8. If the number of side is 12, we can take 12. And D is the distance starting from AB and reaching here. Whatever is the distance covered by the light ray, that is the distance. So this is the Michelson method, and by this we can measure the speed of light in a very comfortable manner. So I am just telling you once again, you see the experimental arrangement is in this way, and the specific speed of rotation omega at which reappearance of the image has taken place in the telescope, sharp and stable image, because once we started rotating the mirror, the flickering of images observed in the telescope. So in this way, I hope that you have understood the Michelson method and Foucault method for finding the speed of light. In the original Michelson time, the mirror used was octagonal, so you will find this formula as 8FT. But if 12-sided mirror is there, we will be using 12FT, 8FD. And after Michelson death, the technology developed and it was 32-sided mirror was also used in this experimental setup. You cannot use less than 8, because if you will use less than 8-sided polygon mirror, then you have to increase the angular speed of rotation to such an extent that the mirror breaks. So minimum is your 8-sided mirror, and that depends upon the situation, that how we are calculating. So this way we are able to find the speed of light using Michelson's method. Hope you have understood this matter. If any doubt is there, then you will put into the comment box and I will try to clarify the doubt. Thank you. Have a nice day.